Hi, I'm Jyri from Emberion, and I want to introduce to our booth here at Automatica in Hall B5 at Machine Vision Pavilion. What Emberion does, we're a company that makes shortwave infrared sensors out of nanomaterials by depositing colloidal quantum dots on top of silicon IC that we design ourselves. So that will make a very unique and high-performing shortwave infrared sensor with high spectral range up to 2000 nanometers and high dynamic range. Now, in order to give the best performance for our customers, we build our sensors into cameras. So we design the camera around our sensor, design the electronics, build it, make the firmware, have our own UI. I invite you to come and visit us and see more what our cameras can do for your machine vision and defense applications. Now, let's go and have a look at the demos we are having here. We have 3 demos here. Here we are showcasing 2 capabilities that Emberion sensors and cameras can do. One capability is the wide spectral range, covering from visible 400 nanometers into shortwave infrared into 2000 nanometers, and that we are demonstrating with our LED system here. We have there 5 LEDs from 1050 nanometers to 1900 nanometers. You don't see them in visible light because they are, as said, invisible light. But here you see them with our camera. They are blinking from 1050 to 1900 nanometers. And there, for example, interesting applications, our sweet spot, so to say, is above 1670 nanometers to 2000, where indium gallium arsenide sensors can't go. Typical areas there is plastic sorting, food sorting. 1920 nanometer water absorption peak is very interesting for our customers, but there are also other spectral peaks, for example, for plastics in that area. So it's a wide range of different applications. Now, I mentioned food sorting and plastic sorting. Their speed is a must. And that's why Emberion has one of the fastest shortwave cameras on the market. Our camera runs full frame, 400 frames per second, and then has the capability to go even up to 1900 frames per second when we do some QVGA with region of interest. Now, what we are here showcasing is a fan, and we showcase how we can stop the fast-running fan with only 200 microsecond exposure time. So we can catch the blades, you can read the Emberion logos on the blades, and we showcase the capability of speed and short exposure time that we can do. The third demo is something we haven't yet ever before shown. So this is the first day we are showing this temperature measurement demo. Here we showcase how Emberion camera can be used for remote temperature measurement above 250 degrees. Here I have a video from our lab where we have calibrated the temperature measurement with 5-degree accuracy. So you see how the ring is heating in front of the soldering iron. So that's a new capability, excellent for any foundries, is it then metal or glass foundry, where you want to see, where you want to protect your camera with a glass enclosure. Now, I should have the soldering iron hot now. Let me have a look. It's warming up nicely, and when I take it out here, you see that the tip is not yet hot. It's just switched the soldering iron on, but you see that the middle part of the iron is heating, and in about 20 seconds, the top of the soldering iron will also be hot. And this is the capability we haven't before shown at any trade fair, and I think it's very important to realize that we go down to 250 degrees, whereas standard in-gas sensors can't go that low, because the higher the wavelength, the lower the minimum temperature is that you can measure. But our camera can go down to 250 degrees. We have tested it, calibrated in the lab, and it's ready to ship. So this is, as we are operating in the about 1850 nanometer spectral area, a unique capability where we benefit of our capability to go to up to 2000 nanometers in the spectral range. Beyond what I was just showcasing you and demonstrating you, we have also some few very interesting developments up and coming. I start from here, from top. We announced that we have the capability to do wafer level packaging. So you just saw the packaging, which is a metal packaging. So we can do in future also that on wafer level without the quite bulky and expensive metal packaging, which will eventually let us go into very cost efficient sensor. We spoke in our release about €50 sensor manufacturing cost, and that would let us to go into areas like automotive, perhaps even consumer, where high volumes are needed, are possible with a very low cost. Then for customers, we will be introducing a couple of new sensors with our next IC development round. One coming from the current VGA into megapixel, but most importantly, our sensor designed for hyperspectral push-broom integration. So it's a monochromatic sensor which we have talked with our customers and listened in the optical sorting area and hyperspectral imaging what kind of sensors they would like to have. And that sensor is meant for hyperspectral integration and has basically push-broom technology in mind. And all this happens in the shortwave area. We will also be extending our spectral range from current 2000 nanometer into higher spectral ranges up to 2500 nanometers. That's interesting, for example, for mining industry or identification. So there are a lot of applications there. And as a final point, in terms of extending spectral range and future products, I want to mention midwave. Midwave is very important in the defense area. We are beyond this machine vision area, we are also very active in the area of defense, but also can be used in machine vision applications like plastic sorting. Like plastic sorting is important. And there we are planning to develop a non-cryo-cooled, TEC-cooled midwave sensor, which is affordable and can bring midwave into novel applications where currently it's not doable due to very high cost. So stay on the channel and wait what Emberion will bring you in the coming years too. Thank you.